This lesson is the first in a short series of lessons on the laws of probability. The basic idea here is that very often when we're making calculations in probability, we have some complicated event that we want to understand, and we try and break it down in terms of simpler events, and we know how to do the probability calculations for the simpler ones. So then the problem is, how do we use those calculations to say something about the complicated event? So this might be easier to understand if I refer to an example. So I'm going to, in this lesson, just go through an example and explain some of the basic ideas of the laws of probability. So let's consider this situation. We have two fair dice and we roll the two dice, and I'm going to look at two particular events. So event A is that the first die shows a 6, and event B is that the second die shows a 6. Okay, so each of these events can be analyzed individually, or we can think of the rolling the two die as a single trial, and we can look at the sample space for that, right? So what's the sample space when we roll two die? Well, we can represent it by a table, a two-way table. So for each die we have 6 possible outcomes, and when we combine the two rolls, that gives us 36 possible outcomes. So I'm going to fill in this two-way table here to show all the outcomes. Okay, so here's our two-way table, and we've got all the outcomes in, and so each outcome is a pair of numbers. When we roll two dice, we get a pair of numbers, and so the first number of the pair represents what the first die shows, and the second number represents the second die. So for example, a 3, 2 down here, that means that the first die showed a 3 and the second die showed a 2. Okay, so here's our sample space. So now we can mark in the two events here on this sample space. So event A, I'll mark that in red, that's saying that the first die shows a 6. So that's all these outcomes here on the bottom row. So let me just shade in that area there. So that's event A. And what about event B? The second die shows a 6, so I'll mark that in green. So that's this column here, right? So this is B. So we can see the two events in the sample space here. Now there are various ways that we can combine these events. We can create new events by combining A and B. So let's look at a couple of examples. We could consider the event which is A or B. So A or B. In other words, either the first die shows a 6 or the second die shows a 6. So that's what we mean by A or B. And often that's written as A union B. We use this union symbol here. So union and or in this context really mean the same thing. So union is the same thing as or. So that in the sample space, that's the union of the red and the green areas. So it's this L-shaped area here consisting of the last row and the last column of the sample space. Now let's say we wanted to work out the probability of that. Well, in this case, all the outcomes in this sample space are equally likely, so we can calculate the probability of A or B just by counting here. The probability of A or B, or A union B, well, the number of outcomes in that event, just count them up and you get 11, and the total number of outcomes in the sample space is 36. So we get 11 over 36. But there are other ways that we could combine A and B. We could look at the event consisting of A and B. So A and B. In other words, the event that is the first die shows a 6 and the second die shows a 6. So now we often write that as A intersection B. And you can see why. In this sample space here, the event consisting of the first die shows a 6 and the second die shows a 6 is just this square down here. It's the intersection of the green column and the red row. And again, we can calculate this probability just by a simple count here. The probability of A intersection B in this case, well, how many outcomes are in this event? Just the one, just this purple box here. So that's 1, and the total number of outcomes is 36. So 1 over 36, right? And also, it's easy to see that the probability of A, well, that's just going to be 1 over 6, right? We have 6 red outcomes over 36 total outcomes, the same as 1 over 6. And the probability of B, well, that's 1 over 6 as well. Okay, so in this situation, we can calculate all these probabilities just by straightforward counting methods. And that's because it's easy to describe the sample space, and all the outcomes in the sample space are equally likely. What the laws of probability do is they tell you in general how these numbers are related. You know, for example, in a more complicated situation, we might know what the probability of A is and the probability of B is, and we're interested in working out the probability of A or B. We have 2 events, either of which could happen, and we want to know the probability that at least one of them will happen. Or we might want to know the probability that both of them will happen. Right? Now, in this case, we don't need any laws of probability to do this calculation, but you can imagine that in more complicated situations, it mightn't be so easy to do these calculations directly. So we might have the probability of A and the probability of B, and we want to work out the probability of A intersection B. So in general, what's the connection here? Well, now, if you look at this example, you might guess a connection here. You have 1 over 6 and 1 over 6, and here you get 1 over 36. So that might suggest something. A little bit harder to see, but you could guess it as well, is how can we get from 1 over 6 and 1 over 6 to 11 over 36? What's the connection there? Okay, so these are the types of questions that the laws of probability will allow us to answer. If we have 2 events and we combine them in different ways, how are the probabilities of all these events related?